Hello everyone, welcome to our 17th video in the Python for Artificial Intelligence and Machine Learning series. My name is Dheeraj Choudhary and today we will explore file handling in Python, in which we will see reading from and writing to files. This is an essential skill for any programmer, but especially important in data science and machine learning, where you will often need to load datasets, save models, and log results. So file handling is fundamental skill in programming that allows your application to interact with external world. Files provide a way to store data persistently, allowing information to exist beyond the lifetime of a program. In data science and machine learning workflows, file operations are particularly important for loading datasets, saving trained models for later use, logging experiments results for analysis, and storing configuration parameters in our machine learning world. So let's understand by looking at this that how we are going to work with files in Python. You first need to open them using the built-in open function that I will show you in the example. So when you open the file by using the open function, it returns a file object that you can use to read from or write to a file. So the open function takes two main arguments, as you can see over here. The first argument is the file name, and the mode, that is the second argument, which specifies whether you are opening the file for reading, writing, or for performing an append operation. After you are done working with the file, it's essential to close it using the close method. Failing to close the file can lead to resource leaks, incomplete writes, or logged files. However, manually closing files can be error prone, especially if exception occurs. That's why Python provides the with statement that we have explicit slide on, where I will talk in depth, which automatically closes the file when the block exists, even if an exception is raised. So this context manager approach by using the with statement is recommended way to work with files in Python. So let's understand how the open and close method works in file handling in Python with an example. So I will just go ahead and talk about this three example. In first example, we open a file called example.txt, as you can see over here, in write mode. So once the file is open, the open function returns a file object which we store in the variable file. Okay, that is this. As soon as you run this, it is going to open this file in write mode, and it is going to return that object into the variable that is file. And when we write the text hello world, as you see over here, into the file, so it is going to write that text into the file that we have opened in the write mode. That is how it works. And once this operation is completed, we will go ahead and we will close this file, because if you are not going to go ahead and close this file, it is going to be a logged file that cannot be accessed again. That I will show you in the second example, that what is the importance of file.close. So when you're not using the close method, how it corrupts the operation and that file cannot be accessed again. So over here, let's understand how we are opening the file. So as soon as you use the open method, it is going to read the file, open the file in the write mode, and it is going to return that object to our variable that is file over here. Then by using that variable, we are going to use the write method to write content into that file that we have opened, and then close to close the file. So if I go ahead, so let me show you the folder. So this is the file open close folder, which is this. So in this right now, you can see there is no file. So when I'm going to run this, it is going to create one file named example.txt. Once it creates the file example.txt, then inside that file, it is going to write hello world. So if I go ahead and run it, you will see it has generated one file that is example.txt with the content hello world. Now, if I want, I can go ahead and delete this file like this. This file has been deleted. Or if I want, I would have also moved that file from one location to other, or made any modification to that specific file, because I have completed the entire operation from opening the file to closing the file. If the file is not closed, what happens? We will see that now. So now in the second example, what we are doing is we are going ahead, opening the file in write mode, which is again going to open a new create a new file that is example2.txt, and we are writing that this might not be saved properly. This is the context that we are going to write inside the file, and we are not closing the file. And when we don't close the file, I will show you what kind of error you might get. So if I go ahead and run this, So the 33 message that you see over here, this is because whenever you use the write method over here, it returns the count of the characters which are being written as part of that specific file. That is why you have got 33 over here. And when I'm going to uncomment this file.close, it will go automatically. So right now I am not using file.close. So in that case, if you can see over here, example2.txt has been created. Okay. Now inside this, you will see that the program was run. Unfortunately, it has not gone ahead and saved it properly because the file is still open, right? So what I will do, I will go ahead and run this again, and let's see if the content has been written now. The file was still open, so this is what happens when you're not closing the file properly, because the file has not been saved. So previously when I opened the file, you saw that there was no content even though the program ran successfully. Second time I ran the program again, and this time it is having the content. Now as it is having the content and the file is created successfully, I will go ahead and try to delete this file, and this will show you that it is not allowing us to do that. The reason for that is a lock is still been established on this specific file. So this is what happens when you're not going ahead and closing the file. That is the reason closing the file is very important. Now I will go ahead and uncomment file.close, and I will run this again. You're not going to see this 33 again because the last code that runs is close, which is not going to return anything. Okay. So now in this, we have closed the file. So now if I go ahead, and you will see that the file has the data, and as well as if I want to delete this, it is not going to give me any error because the file is not been locked by the program. See, the file has been deleted successfully now without any issues. So that is the importance of file.close that you should be aware of. Now, in the third example, what we are seeing over here, I was talking about with statement. So there are two ways of opening a file. So one, you open the file and close it. Okay. And in other, if you're using a context manager, that is the with statement, you don't have to close the file. It will automatically close once the operation has been completed. So over here, what I'm doing is I am just using with open. So instead of open, I am using the with statement. This with statement is going to open the file, perform the operation, and close it automatically. That reduces your effort of writing the file.close manually. So if I go ahead and run this, so this time example3.txt has been created, and if you see, the data will be written properly, as well as if you want to delete this file, it is not going to give you any error because the file has been closed automatically by with statement itself. That is the reason using the with statement is a go-to approach when you don't want to get into the hustle of declaring this method close over here. So let's see what's next. So next we are going to talk about file modes. So when we are opening a file, you need to specify a mode. As we saw, this is the second argument, right? The first argument is the file name and the second argument is the file mode. So you need to specify a mode that determines how that specific file that you are trying to access will be accessed. So the most common modes are, as you see, it is for reading, W is for writing, A is for appending, and a reading mode opens an existing file, as we saw, for reading, and raises an error if the file does not exist. So that I will show you in the example. So, and in the write mode, it creates a new file or it truncates an existing file, which means any existing content in the file will be truncated when you're going to use the write mode. For example, in my file right now, I have three names, name A, name B, and name C. Then when I go ahead and again open that in write mode and make any modification, those all three names will be gone, and the new data that you are passing as part of that write operation is going to be written over there, and the previous content is going to be truncated. That is how it works when you use the write command. Now, appending mode opens a file for writing without truncating it, like write, and it is allowing you to add content to the end of the file. As I said, if we have three names in the file, name A, name B, name C, so if we are going to use append mode, it is going to add our new content after that three names that we have already defined. Now, the X mode is exclusive creation, which fails if the file already exists. So if the file already exists, it is not going to create a new file, but in the mode that is write and append, if the file does not exist, it is going to go ahead and create a new file. And by default, files are opened in text mode. But if you want, you can use binary mode B for non-text files like images. These modes can be combined For example, you can write a read binary. For reading a binary file, you can use AT. If you use RB, that is read binary. If you use WB, that is write binary, that is write to a binary file. If you use AT, it is append a text file. So that is how you can use multiple combination based on the requirements that you have for performing your file handling operations. Now let's understand all this mode of files with an example. So if I jump to our editor, let me close this, and these are our file modes. So in this file mode, first I will show you that right now, if you see in this folder that is file modes, there is example.txt file which is already existing. I have added that. There is a reason for that, because if for read mode the file does not exist, it is going to give you an error. So right now I have changed this file name to from example to example1, and if I run this, it is going to throw an error saying that file not found error. See, file not found. Now, if I remove this and run it, you will see there is no error and the file was read successfully. So for read, whenever the file is not present, it is going to throw error. So you have to make sure that whenever you're trying to read a file, it exists in the system. Now, for write operation, it is not the same. So now I am in the same folder, that is file modes. You don't see the file named new file.txt, but when I'm going to run it, it is going to create that file for us. So you can see over here, now the new file.txt is created, and the content that we have passed as part of file.write method, it is also been added to our file. That is how the mode W works in file handling. Now we are going to talk about another mode, that is append. But this time I am not going to modify the same file purposely. Instead, I am again going to create a new file. So the way in write mode, the new file is getting created if the file does not exist. The same way it works in append mode also. So if you see in file modes right now, I don't have any file log.txt. But if I go ahead, okay, and run this, you will see that it has created the new file, that is log.txt, and it has added the content to it. Now, if I go and run this code again, it is not going to overwrite it. So it is going to go ahead and add a new entry. That is the beauty of using append mode. But if I go over here and open this new file.txt that we created in write mode only, okay. So if I change the text over here as X, Y, Z, before running, I will show you this is the current content of the file. And when I go ahead and open it at write mode again, it is going to overwrite that content. And now you will see the content has been changed. From the previous one, it is truncated, and the new content is XYZ. And that is the difference between the write mode and the append mode. Now let's talk about another mode, that is X mode. It checks whether the file exists or not. So if I go ahead and run this, so you can see a file has been created. So this exclusively checks if the file exists or not. So when I ran this, it checked file exists or not. If the file has not existed, then it has gone ahead and created one, and it has given that message that this file is created only if it does not exist. So if the file exists, it is not going to go ahead and create it. So next time when I'm going to run this, see, the file exists. So if the file is going to exist, it is not going to run. If the file is actually existing, then it will give this error. So I will just clear this output. Now let's move to the next one. So this example says that here we open a file in text mode, which is actually default. Even if you don't, it is by default going to open in text mode. And as I said, you can specify text with different operations. So over here I have said that I am opening this file with read text mode. So I am opening this file in read mode, and the file that I'm going to read is going to be in text mode. So this tells Python to treat the file content that has been written in that file as text. So if there is any other content which is not text, mathematical expression or something, it is not going to understand it. It is going to throw an error. But when I'm saying in text mode, that means we expect that the content of that specific file is going to be text. So if I go ahead and run it, it is going to show us the content of that specific file, that is hello world. Now this is the important one. So binary mode, when you have to actually go ahead and read an image, in that at that time what you will have to do is you will have to use uh, uh, binary mode over here. So this file is going to be read in the binary mode, where you will see that when I go ahead and run it, so this is the image that is present over here. It is going ahead and reading this file, and it is giving you the output over here accordingly, saying that this is the length of the bytes for that specific image. So this is how you read the file that is binary in nature. Let's see what's next. So now, as we know, Python provides several methods for reading file content, each suited for different scenarios. The read method reads the entire file at once, which is convenient for small files but inefficient for large ones. If you are going to use read and you're going to read a very big file, all that content is going to be in your memory, and it's not a good practice because it will slow down your efficiency. So you can also pass a parameter when you're going to read the line if you want to avoid this. So when you use read n, so n is the number of characters that you want to read. So if you know that to run my program efficiently, this is the specific number of characters should be in, which should be in my memory, not more than that. So in that case, you can use read n. Now, for line by line processing, you can use read line that you can see over here for line by line for a single line processing, and read lines to get all the lines as a list. Or if you want to simply iterate over that file object, so you can use the iteration over there. So when you're reading the text file, these methods return strings, but for binary files, they return byte objects. So it's important to consider the file encoding when you are reading this file. That is UTF-8, which is most common encoding for Unitext, but you may need to specify different encodings for certain files. So right now we are only going to cover UTF-8, but there are different Unicode formats also. If you have to read those kind of file, you have to mention that explicitly while you are reading that file. And in data science and machine learning, you will often load text-based datasets like CSV files using these methods before converting them to more structured formats based on your requirements. So let's understand with examples that how these read file function methods work. So the first one, in this, what it does is with open, I am using with open, that is the context manager. So no need to close the file. So this will open the file, read the file, and I'm printing the content of the file that has been read. So this is reading the entire file, and I am printing the output over here. Okay, as it is. Whatever, suppose if there would have been 1000 line, it would have read everything and kept that in memory while it is reading the file. Now, when you have to read line by line, in that case, so when you have to perform any specific operation on each line, in that case you can use the other method where we use read line. So in this, what we are doing is we are actually over here we are using line by line. We are doing an iteration on each line of our file. So when we read the object, that is the file, it returns the object, then we read it line by line. So we are writing a file loop over here. So when we use with open read line .txt in read mode as file, it has returned the object of the entire file. Then in for loop, we are iterating over each and every line. Once we go to the first line, then we are using line.strip. What it does is it is going to remove the leading trail and the end trails of the file. So over here, if you see in the first output, example.txt is having some content which is having leading spaces, okay, and trailing spaces too. Now, if you want to remove that, you have to use strip function. But if you have to do that in a iterable manner, in that case, you can use this read line by line iteration, which helps you to strip that out. And when you run it, right now you can see that the spaces in line 1, 2, and 5, 6 has been removed successfully. So now when you want to read all the files as a list, so I have used file.readlines over here. So if I go ahead and run this, so if you see, so there are supposed to be 6 lines. So it has given us the count. So it is reading all the lines, and when we read all the lines at that time, see, it returns a list of lines from the stream. So it has returned the list, and then it was easy for us to perform the other method, that is length, which based on the returned list of the lines, we were able to count the length of the lines inside that file. That is how you can use read lines. Now let's see another example. So in the third example, sorry, not the third example, this is the fourth example. So I have written two types of code over here. So let me first show you the file so that you will understand what exactly we are doing now. So if I go in read file, I have a Unicode file with Unicode context over there. So hello world, first time I have written that in English, second time I have written that in Hindi, and third time I have used emojis. So these are all Unicode characters, considered as Unicode characters. Now, as I said previously, that when you are trying to read a file which is having a Unicode context, you cannot use the same read method without mentioning any specific Unicode. If you do that, it is going to go ahead and give you this kind of error, as you can see below. Unicode decode error. It is not able to decode the file because for him it is reading that as a text file only. That is a default one. But you have to explicitly tell them that this is not a text. You don't have to read this file in text mode. You read this file in Unicode mode, and when you do that, it is able to read it properly, and you can see the content has been read exactly as it was in the file. So that is how the beauty of using an encoding. So the encoding that we have used over here is UTF-8. It told it that you have to read this file, that is an encoded file, not a text file. So now let's talk about writing to files, which is done using a write method for a single string or write lines for a list of strings. An important detail to remember is that these methods don't automatically add new line characters. You need to include /n explicitly where you want line breaks. I will show that in the example. When you open a file in write mode, that is W, Python will create the file if it does not exist, as we saw, or it will truncate it if it is already existing. So both write and write lines return the number of characters written, which can be useful for verification. So previously in one example, I showed you that file.write, then we gave some string that was written, and it returned us the length of the characters in that string that we had written. That is how write and write lines, both of them returns the length of the characters which has been written. So in machine learning application, you might use this methods to save models, model parameters, write configuration files, or create log file to track experiment results. So let's understand writing to file with few examples. So in our first example, what we are doing is, so we open the output.txt file in write mode. So first, let me take you to the write file. So in write file right now, I don't have any file. So when I'm going to run this, it is going to create an output.txt file as part of that specific folder. Okay, so this creates the file if it does not exist. So we will use file.write to write text into the file that has been mentioned over here, that is hello world. Now, after that, when you have to put text on the new line, you have to explicitly mention /n at the end of hello world. So /n is a new line character. So the next line starts on a new line. So if you don't add /n, all text will stay on the same line. So that is how you have to handle the write method. So if you have multiple things to be added as part of this, as part of the code, as you can see over here. So if I go ahead and run this, so you will see that a file has been created successfully. If I click on it, this is hello world, and the other write operation was performed on the another line by using /n. Now let's see second example. So in this example, we want to write several lines in one go. So we can create a list called lines, as you can see over here. And as it should not come all in one line, I have used /n for each one of them. So right now we have, we created a list called lines, and each item is line of text, and we have manually added /n to each one to move to the next line. So we then go ahead and use open, that is open multi-line.txt file, which is again not existing. It is going to go ahead and create a new one, and it is going to add this over there. So then we go ahead and say write lines. So now it is going to go ahead and write the files appropriately. So if I go ahead and run this code, let's see what's the output of the new file. So see, it has gone ahead and written each and every content on the new line. So that is how it works. write lines. So now let's see in our last example, we are going to use a loop to write formatted lines into a file. So we open the data.txt. Again, that file is not existing over here as part of this folder. So when we are going to run this command with open w, it is going to create the new file, that is data.txt. Once it is going to go ahead and create that file and open that in write mode, then we will use a for loop to go from the range of 1 to 5. On each loop, we are using an f string to write something like line 1 colon 10, line 2 colon 10, and so on, for which you can see the operation has been performed over there. So when it starts with range 1, so it will be 1 into 10. Then when it goes to range 2, it will be 2 into 10. Likewise, we have manipulated the output, and we are printing that each one of them on the new line by using /n over here that you see at the end. So if I go ahead and run this code, it is going to create a new file, and the code is like this. This is how it has been written on the new line. So these are the various ways by which you can use write and write lines to write your code. Now, let's talk about appending to file. So append mode specified by a character when opening a file allows you to add content to the end of a file without erasing its existing contents, as we saw. So if the file doesn't exist, Python will create it just like in write mode, as we saw. So when you open a file in append mode, the file pointer is automatically positioned at the end of the file. So any write operations add contents after the existing data. So you can use the same writing methods as in write mode, that is a write method for single string and write lines for a list of string. And append mode is particularly useful for log files where you want to add new entries without overwriting previous ones, or for incremental saving results for long running processes. Many a times, if you have written an application and you are logging the results of those application, and you have to understand that operation of that application into a flow. So you are not going to overwrite the events which are being triggered as part of that application. It should be in a synchronized manner, so you can understand that which triggered first and which triggered second. So in that case, you can use append. You can write to the file in append mode. So let me go ahead and show a few examples how we can do it. So in the first example, we open a file called log.txt in append mode. So let me first take you to the append file folder. So this is the append file folder, and you will see there is no file over here. So when we are going to use with open append file log.txt, the first thing it is going to do is the same way like write, it is going to create a new file, and that is going to be in append mode. Once the file is created, the append it is not going to overwrite the file. Already the file is not having any content, but we will run this program 2 times. So you will understand that when you're using the append mode, it is going ahead and creating the file for the first time. Okay, log.txt. Now, if I go ahead and run this again, every time it is going to create a new entry over here. Then I will run this again. Again, it will go ahead and create a new entry. This is how the append mode works. Now, in the second example, we see that this has created a new file as it was not existing. So when we open the new text file.txt as file, oh sorry, I will have to use the same. Okay. So in this, what I have done, so previously I was running the same code again and again and again. So you are seeing that new entries are getting created. But in this example, what I'm seeing that if the file is already existing, what we are going to do is we are going to run this, and it is going to append that in that existing file. So you will see the previous entries are as it is, and the new code has went ahead and appended that in the append mode. Now, last example, which is an practical example. So we show how append mode works in real situation. So imagine you are training a model for 5 epochs. For each epoch, you calculate some fake matrices, that is accuracy and loss, for a specific model that has been running for each epochs. So then you open a log file in append mode and write the results for that epoch which has been executed. So each time through the loop, new results are added to the end of the file. So this way your training log keeps growing with every run and never lose earlier results, because every epoch helps us know that how the model is performing in each epoch. So it is incremental or it is decremental. So if I go ahead and show the output, minimize this. So this is our training. So see, so in our first epoch, the accuracy was 0.60, like 60%, then 70%, 80%, 90%, then 100%. So that is how you can append the epoch frequencies for each epoch, not frequencies, epoch statistics for each epoch to understand the accuracy and loss that is being performed as part of that specific epoch experiment that has been done. Now, let's talk about with statement in deep. So the with statement is context manager for resource management, as we know, and it's recommended way to work with files. So when you use with statement, Python automatically takes care of closing the file when you exit the block, even if an exception occurs inside the block. I will tell you that if exception occurs, how you have to handle that too after this one. So you can also work with multiple files in a single with statement by separating them with commas. That I will show you with an example. Always prefer the with statement for file operations. It's not only cleaner, but also safer by guaranteeing that resources are properly released. Because if you're not going to go ahead and use the close method, it is going to give you the problem as we have seen. So let's understand this with a few examples. So I have 3 examples for with statement. So the first one over here, it is going ahead and reading the content. If you want, we can print the content too. So I will just go ahead and run this. So it is going ahead and reading the content from example.txt file, which was already existing. So it has, so we have the same output as we had it previously. Now, when you have to use read multiple lines, so in that case, you can also do that in read statement. That's what I was talking about. So when you are using only open without with, you have to use one file read one file at a time. But when you're using with with statement, you can open multiple files together. So right now, what I'm doing is, so we open 2 files at the same time using one statement. So we open input example.txt in read mode and output.txt, that is the second file, in write mode. 2 different modes we are opening the file at same time. Then we read the input file's content, that is example.txt, and we write it to the output file with a keyword that you have seen over here, output file dot write, that is processed and the existing content. So you can see that how we are doing multitasking, where we are opening multiple files. After we are opening multiple files at runtime itself, we are copying the content of one file and copying, sending it to the other file. So right now, if I go ahead and run this, it is going to, so the example.txt that you see over here, so this was the output, right? So now if I go ahead and print this content again, you will see that the output have changed. See? Okay. Oh, sorry. This is, I am printing the wrong content. It will not show here. It will show us in with statement folder to the new file. I was opening the content C. So processed word keyword has been added. So what it did is this output.txt was empty. We created that at runtime because it was in write mode. That file does not existed. Then once it was created, then at that time it copied the content from example.txt to output.txt. Maybe I have not showed you the file before. So this time what I will do, I will go ahead and delete this file in front of you. Now we are going to go ahead and run this program again, and you will see over here a new file will be created and the content from file 1 will be transferred to output.txt. If I go ahead and run this now, it is not going to give any output, but yes, new file has been created and you can see the content has been transferred from example.txt to this one. So this is how it works. Now in our last example, we open file without using a with statement to see how complicated it becomes, and it is not recommended. So if I go ahead and run this, so in this, what we are doing is we are going ahead and reading the content. But when you're not using the with statement, then you can use the finally clause, because finally clause is the one which is going to run no matter what your code is going to run, or it is going to give an error. So right now, if I am doing file.read example.txt, okay, this program has executed successfully. Even if I use this and run, see, file not found error we have got, but it has closed the file again because of the finally block. So in cases where you don't see the with statement over there, what you can do is you can use the finally block, because you have to make sure that the file which has been opened has to be closed. So if you are using context manager, it will be closed automatically. If you're not, you have to make sure you use a finally clause or close it manually by defining it somewhere, that is file.close. So now next we would be talking about working with file paths. So when we are working with files, you need to specify their location using file paths, which can be either relative to your current directory or absolute from the root of the system file. So Python's os.path module provides functions for working with paths in a cross-platform way, handling differences between operating systems like Windows using backslashes and Unix like systems using forward slashes. So the os.path.join function is particularly useful for creating paths that work on any system. Other helpful function includes os path.exist to check if the path is existing or not before performing any operation, right? And in Python 3.4 and later, from Python 3.4 and later, the pathlib module provides an object-oriented approach to handle the path handling, which many people find more intuitive compared to the older one, that is the os.path. So in ML projects, proper path handling is essential when working with dataset, model files, and output directories across different environments. So let's explore how we should work with file paths. So if I go ahead and open this, so in the first example, we use the OS module, that is the default one. Okay, so we are going to use the OS module to build file paths. So we have a folder called data. Okay, now and a file called data.csv. So I'm just going ahead and removing this. So what we are doing is we are defining two, and then we are using os.path.join, and we are going ahead and creating a file path by using this join method over here. So the best part is it will automatically use the write separator based on your operating system. So usually what happens that if I am going to go ahead and manually add this file path, this might work in Linux, this might not work in Windows, right? But this is Windows. So if I'm going ahead and running this, and I will print the file path, as this is Windows, it is going to use the backslash. If I would have used that in the Linux environment, it would have used the forward slash. So this is the beauty of using the path.join, where you don't know which operating system the code is going to run. In that way, you can use it anywhere. Now, in a second example, here we are going to use os.path.exist method. So we use this to see if the file exists or not. So right now, in our first one, data.csv file actually exists. I will show you. The data folder is over here, and as part of this data folder, data.csv is already there. Okay, so what if os.path exists? Okay, so in that case, first I will go ahead and change this over here and run this. So if the file is found, we are going to open that in read mode with the with statement, and we are going to read that read its content. If it does not, we are going to print a clear message saying that this file does not exist. So right now data1.csv does not exist. So it will go to the else part, and it will say the file data.csv data1.csv does not exist. Now if I go ahead and change this, and now I run this, it is going to actually print the content of that file that you will see right now. Let me run this. So now this is data.csv, and when see, so the if statement first, it checked if the path exists or not. Yes, the path existed, then it went ahead and opened this file, and if it does not existed, it went to else. So that is how you can use path.exist to check if the file path actually exists or not. Now in the third example, we use the pathlib module that I said that which is available from Python 3.4 onwards. So which is more modern way to handle file paths in Python 3.4 and later. So over here we will create a path object for data folder, and then we are going to use slash to join paths in an easy way, easy readable way. So over here what I have done is I have used path, and I am going to go ahead and use our file, that is data.csv. So this is better compared to the previous one, because previously we were going ahead and creating two different variables, storing values in them, and then we were going ahead and using. So over here we can directly go ahead and define them over here as part of by defining this path as part of the pathlib module, which is easy to read. Now if I go ahead and run this, it is going to go ahead and read the content of the file. Right now I'm not printing, but it has read the content of the file properly, so it is working. So if I am going to use this, so I'm not sure, no, it is not going to give any error because I don't have any else block. So that is how you can use pathlib in cut short. Let's move next. So now, when working with files, various errors can occur. We saw a lot of errors, right? And it's important to handle them gracefully to prevent your program from crashing. So common file related exception include file not found error, which we already saw when the file doesn't exist. Permission error we have not seen, but if the file does not have permission, then a necessary permission, and when you try to access it, it is going to give you an error. Is a directory error. So when you are trying to open a directory as a file, at that time you're going to get an error saying is a directory. And IO error for general input output errors that we have from our system. So note that the with statement ensures that the file is closed even if an exception occurs, but it doesn't prevent the exception from being raised. So in some cases, it's better to check if the file exists before trying to open it, especially if you have a specific alternative action in mind. Robust error handling is particularly important in production machine learning systems where data files may be missing or inaccessible. Now let's understand that what are different kinds of error which comes and how we can handle it gracefully by using our error handling techniques that we have learned in our last tutorial. So in our first example, the code tries to open non-existent .txt file. So if I go file handling, so file handling is over here, and in this you can see there is no file currently which is existing. Okay, and as we saw, if you're trying to open a file in read mode which is not existing, it is going to throw an error, and that error is file not found error. That is an exception, and we are catching that exception over here. Okay, so the except block is going to catch this error, and it is going to print a friendly message saying that the file does not exist, creating it. Once it gives that message, then it is going to open the same file in write mode. After we have caught that exception, we are doing a remediation, saying understanding that we are trying to access a file which does not exist. So instead of read mode, we should open that in write mode so that the file will be created and the operation will be performed successfully. So if I go ahead and run this, it is going to create a new file over here, even though the file was not existing. So what we did is, first the file was not existing, it raised an exception, we caught the exception, and then we said that this file does not exist, creating it. We printed here. Then we again used a with open, where we opened the file in write mode, which created the new file, and then we have gone ahead and written that in file, that newly created file. That is how you can handle your errors while performing operation onto the files. Now let's understand another example. So in second example, we show how to handle different file related problems separately. So the try block tries to open the secret.txt file which does not exist and read its content. So if the file does not exist, we are going to get file not found error, and the file not found error block is going to run, file not found is going to be printed. And if you don't have permission to that specific file, a permission error block that you see over here, that is the permission error block exception, is going to run. If this file is not a file, it is a directory, it is going to go ahead and print this message. And if there is any unexpected error or exception which is going to be raised, we are going to handle that as part of this. So this is how you can handle multiple use cases by using try except block as part of your file handling scenario. So even if I run this file, so as this file does not exist, so it is going to say you file not found. But if the file is already existing and you don't have permission, it will go to next. If it is a directory, not a file name, it will go next. So this is how you can handle multiple errors in one code itself by using file handling. Now, very important, CSV file, that is a comma separated file, is one of the most common file formats for data sets in data science and machine learning. While you can read CSV files as regular text files and split lines manually, Python provides the CSV module, which handles details like quoting and escaping special characters that are being defined as part of your CSV file. So the CSV.reader and CSV.writer classes provide basic CSV file handling operation, while CSV.dictReader and CSV.dictWriter allows you to work with CSV data as dictionaries using the header row for keys. Note the new line, that is new line is equal to parameter when opening a CSV file, which is recommended to handle line endings consistently across platform. So for data analysis and machine learning work, the pandas library provides more powerful tools for working with CSV file with its read_CSV or to_CSV functions that directly converts between CSV files and data frames objects. So working effectively with CSV files is essential for most data science and machine learning project, as CSV is the common format for sharing and storing tabular data of the applications or the businesses which are been running. So in the example, we will see with two examples that how you can work with CSV file by using these file handling operations. Okay, let me go ahead and clear this. So in the first example, what we are doing is we are going to use a built-in CSV module to read the data from the CSV file. So we are going to use data.csv. So we are going to use data.csv, which is our file. So if I go to file underscore CSV, this is the folder over here. Okay, so in this already we have, I will just remove this file. So in file.csv right now you can see that there is already an existing file, that is data.csv. This is the file data.csv, which is having two columns, income and happiness. So based on the income, this is the account measure of the happiness of a specific person. So what we are doing over here is, so we open the file in read mode, as you can see, and pass it to csv.reader, which reads each line as list of values. The first line of CSV file is usually a header that we see, right? When we open the CSV file, you will see that those files are having a column name. So consider them as headers. So we use next CSV to skip that row. CSV reader.file. First we are reading that file. Once we read that file, then we say header is equal to next. So over here we are going to leave this income and happiness, which are the column names for us. Once we leave that, then we are going to go ahead and iterate over our csv.reader. First we loaded the entire content, then we removed the header, and now we are going to iterate over each one of them. So this is how you can iterate over each one of them. So, and if I go ahead and run, it has been iterated over each one without the header, and that is how you can read the CSV file line by line. You can print it, or you can take it as an object and perform any operation based on your requirements. Now we are in the second example. We will use a new CSV file called output.csv, which does not exist. So we open it in write mode, and we pass it to csv.writer. Previously we have seen csv.reader, which was going ahead and reading an existing file. This time we are going ahead and opening and non-existing file, that is output.csv. So for that, what we are doing is we are going to go ahead and say new line, so that each row that we are writing, it is going to be on the new line, as you can see. So yes, so over here first we are creating we are calling csv.writer. It is going to go ahead and it is going to get the file which has been opened. So once we open this file, it is going to return that object. Once we get that object, that we are going to perform the operation one by one. So first we are going ahead and we are going to define our headers, that is name, age and occupation. Then we go ahead and write the columns or the data that we have for the specific columns that we have created. So if I go ahead and run this, so you will see that it has actually gone ahead and created a new file, and the data is as expected. So first we have the header, and after that we have the content for the specific header columns that we have created. So this is how you can use csv.writer for to write to your CSV file. Now let's talk about some best practices for file handling, which will make your code more robust and maintainable. Always use the with statement to ensure the files are properly closed, even if exception occurs. So check for file existence before opening if your program needs to handle missing files specially. As we saw, there was one method where we saw that dot exist, which will tell you that the file path exists or not, which will indirectly tell you that the file is available or not. So based on that, if you don't want to create the file and you have to perform some other operation, you can do that by using that dot exist in a if condition. And use appropriate error handling with try except logs to catch file related exceptions. When working with binary file like images, use binary mode B, and for text file use text mode T, and explicitly specify the encoding, usually UTF-8, to avoid character encoding issues, if any, if you're trying to read a file which might have encoding characters. And for large files, read in chunks or line by line to avoid memory issues, because if you're going to read the entire file at one go, it is going to be added to your memory and it is going to slow down your process. So use specialized modules for specific file formats that we saw, like for CSV. For CSV, you can use their specialized file modules. You also have JSON that we have not covered, but there is specific modules for that too. The way we use CSV reader, there is the same is for JSON. Then we have a pickle for serializing Python objects and pandas for data analysis task. So these are the further advanced libraries that we'll be covering in our upcoming sessions. So thank you everyone for your time and participation. I encourage you to experiment with the concepts we discussed today. If you have any questions or thought, feel free to drop them in the comments below. I would love to hear from you. Remember, programming skills improve with practice, so try to apply these concepts in different contexts to solidify your understanding. Join our WhatsApp community, subscribe to our artificial intelligence and machine learning YouTube channel, and sign up for Tech Insight Neuron newsletter, because very soon we are going to start the blogging series for the entire tutorial that we have in Python. So whatever code we have, you will find that code into that blogs, and you can copy them, download them, and you can execute them. So see you in the next video. Take care and bye for now.